So let's talk about an idea that's really shaking up our classrooms. What if we just knock down the walls between school subjects? What could we build then if we built something more powerful together? I want you to think back for a second, back to your own school days, right? Remember how math and science and English felt like they were on completely different planets? One minute you're solving for X, the next you're dissecting a frog, and there was like zero connection between the two? Yeah, that's a model we all know really well. Every single subject gets its own little silo. It's totally walled off from everything else. But what if that separation, that way of doing things, is actually holding our students back from getting a much, much deeper understanding? Okay, so here's our game plan. We're going to start by digging into why these separate subjects can be a real problem. Then we'll introduce this new approach. It's called STEM PBL, and see what makes it so powerful. We'll even look at how it can be mixed into the classroom in different ways. And finally, we'll get down to brass tacks. How do you actually do it? And what are the real-world pros and cons? Let's get into it. So you might be thinking, what's the big deal? What's the actual harm? Well, the research is pretty clear on this. When learning is all chopped up like that, students really struggle to see the connections. They just don't get how algebra relates to physics or, and this is the big one, how any of it connects to their own lives in the world waiting for them outside the classroom. So how do we fix this? How do we break down those silos? Well, there's this amazing approach called Interdisciplinary Stem project-based learning. We'll just call it PBL. And you can really think of it as the bridge, the thing that finally connects all those separate worlds of knowledge. So what is PBL, really? Well, at its core, it's about totally flipping the script on the classroom dynamic. We're moving away from those short, teacher-led lessons, you know the ones. Instead, we're diving into long-term, student-driven projects that tackle actual, real-world problems. And you can really see the difference side by side, can't you? A traditional classroom, you get a clearly defined task, and the teacher basically hands you the knowledge. But in a PBL classroom, the task is ill-defined. That just means it's a messy, complex problem with no single right answer. Students have to work together, and the teacher, well, they become more of a guide, a facilitator, helping them figure out how to solve the problem for themselves. It's a huge shift, right? From being dependent to being an independent problem solver. Okay, so let's get to the heart of it. Why does this connection matter so much? What actually happens when you stop teaching science, technology, engineering, and math in their own little boxes and start mixing them all together? Well, the benefits are huge. We're talking about building higher-order thinking skills. It helps students finally connect the dots and see the bigger picture. This leads to a way deeper, more lasting understanding of the concepts. And get this, research shows it can actually improve student achievement and motivation, probably because they can finally see the why behind what they're learning. Okay, let's make this less abstract. Check out this example, the chilling project. You have students from math, science, and tech classes all working together on one single goal: build the absolute best ice container possible. All of a sudden, those math formulas for volume and surface area, they're not just numbers on a page anymore. No, they're the key to winning the challenge. See? That's PBL in a nutshell. Now, I know this might sound like a massive all-or-nothing change, but it's really not. It's better to think of it as a spectrum, a journey. So let's walk through the different levels of how you can integrate this stuff. All right, we start at level 1. This is the classic setup, the silo. Math happens in math class, science happens in science class. End of story. The walls are high and thick. This is probably what most of us remember. Then you move up to level 2. Here you might get a themed unit. So maybe the whole grade is studying ancient Egypt. The history class talks about pharaohs, science looks at mummification, and English is reading Egyptian myths. The classes are still separate, right? But now there's this cool common thread tying them together. Level 3 is where things get really interesting. This is where you get true multidisciplinary work. Now, teachers from different subjects, say math and science, are actually in a room together, planning projects together. They're intentionally weaving their subjects into one single experience for the students. And finally, you hit level 4, total integration. This is the holy grail. At this point, the boundaries between subjects basically disappear. They dissolve. Learning just flows from one discipline to the next so smoothly that a student isn't in science class anymore. They're just solving the problem. And this table just lays it all out so perfectly. As you move from level 1 over to level 4, just look at how the roles completely flip. The teacher goes from being the giver of knowledge to a facilitator, and the student, well, they go from being a passive receiver to an active knowledge gatherer, working with a team. It's a total transformation. Okay, this all sounds great in theory, right? But how does a school actually pull this off in the real world? It really boils down to 3 key ingredients. First, and this is the big one, you need teacher collaboration. This cannot happen if teachers are working alone in their silos. They absolutely need dedicated time to plan together. Second, use cool tools like concept mapping. This helps everyone visually see how different subjects like physics and art can connect to a central theme, like a rocket project. And third, you bring the real world in, partnering with local businesses, museums, you name it. That's what makes the learning feel authentic and important. All right, let's be real for a second. Like any big change, this is not a magic wand. It's not perfect. So it's super important to look at this with a balanced perspective, the amazing advantages, but also the very real challenges. On the plus side, the advantages are pretty incredible. You're getting rid of that fragmented, chopped-up curriculum. You're building deep, conceptual understanding. You're actually empowering students to take charge of their own learning. And it's flexible, which means teachers can get creative while still hitting all their curriculum goals. But then you have the limitations, and they are not small. Finding that common planning time for teachers, that's a logistical nightmare for most schools. And having no set textbook or routine, that can make both teachers and students pretty uncomfortable. You might even get some pushback from students at first who are used to the old way of doing things. Hey, why are we doing math in science class? But I think this quote from Alan Zolman just perfectly captures the whole philosophy here. He said that STEM areas can't be seen as independent silos. Instead, they should be seen as a meta-discipline, a single integrated field of study. That's the core idea. And that really brings us to the so what. Why does all this matter? Well, think about the biggest problems our world is facing right now. Climate change, public health crises, economic inequality. None of those problems fit neatly into one little subject box, do they? They are messy, they are complex, and they are totally interdisciplinary. So this isn't just a different way to teach school subjects. It's about preparing students to solve the real problems that are going to define their future. So I want to leave you with this question to chew on. Just imagine, what incredible, world-changing problems could the next generation solve if, from the very beginning, we taught them how to learn and think without any boundaries at all?